Silicon microchips drive modern capitalism, and one small island completely dominates their global manufacturing network. Without Taiwanese chip fabrication plants, the global supply of computing power drops instantly by half, paralyzing vital international industries. For advanced processors under 10 nanometers, global dependency is absolute, with Taiwan manufacturing over 90% of the total market supply. This concentration means international tech corporations have zero immediate alternatives for sourcing the hardware that runs their consumer applications and data infrastructure. In 1987, Morris Chang founded the Taiwan Semiconductor Manufacturing Company, inventing the pure-play foundry business model that transformed electronics. This model decoupled design from fabrication, allowing software startups to design complex chips without spending billions owning and operating highly specialized physical microchip production factories. Modern semiconductor fabrication demands unprecedented capital. Developing a single state-of-the-art factory today requires an investment exceeding $20 billion, creating an extreme financial entry barrier. Beyond capital, Taiwan established a hyper-dense industrial ecosystem where component suppliers, chemical engineers, testing centers, and assembly operations live within miles of the core foundries. This geographic clustering optimizes logistics to an extreme degree, ensuring that operational friction is minimized and production velocity remains unmatched by any distributed competitor in Europe or North America. The manufacturing process relies on extreme ultraviolet lithography systems sourced from the Netherlands. Taiwanese firms purchased these multi-million-dollar machines at a scale and speed that locked out market rivals. Major technology giants, including Apple, NVIDIA, Advanced Micro Devices, and Qualcomm, build their corporate empires on this foundation. Their most advanced, highly profitable hardware architectures are realized exclusively inside these specialized East Asian manufacturing cleanrooms. An abrupt halt in Taiwanese exports would trigger an immediate systemic crisis, freezing consumer electronics assembly lines, halting global automotive production networks, and entirely stopping the scaling of large data centers operated by major cloud service providers. Economic forecasters project that a serious supply disruption in the Taiwan Strait would instantly delete over $2 trillion from global gross domestic product within the first 12 months, far exceeding the financial damage caused by recent global market shocks. The core competitive advantage is not just owning advanced machinery, but mastering yield optimization. Taiwanese engineers achieve high percentages of non-defective chips per silicon wafer, keeping production costs low and rendering competitors financially non-viable. Decades of high-volume manufacturing have yielded an invaluable learning curve advantage. Thousands of highly proprietary process adjustments are passed down through specialized engineering teams, creating operational knowledge that cannot be easily copied from textbooks or patents. The artificial intelligence revolution relies completely on specialized graphics processing units capable of processing massive data parallelisms. These highly sought-after accelerators are fabricated almost entirely within a handful of heavily fortified Taiwanese industrial business parks. This massive economic integration gives rise to the Silicon Shield geopolitical strategy. Because global capitalism depends on Taiwanese hardware for its daily survival, major international military powers are structurally incentivized to ensure the island's stability and security. Recognizing this extreme geographic vulnerability, Western governments are deploying hundreds of billions of dollars in public subsidies to reshore chip manufacturing, funding domestic projects across the United States and various European Union member states. However, direct government funding cannot instantly recreate a deeply integrated industrial ecosystem, replace decades of specialized vocational workforce training, or match the hyper-optimized infrastructure clusters that have matured over 40 years in Taiwan. To manage geopolitical pressure, Taiwanese corporations are building satellite factories in Arizona, Japan, and Germany. Yet, the corporate strategy keeps the most advanced research centers and next-generation production nodes concentrated strictly on domestic soil. As manufacturing roadmaps push deep into the 2-nanometer frontier and beyond, engineering challenges related to quantum interference multiply exponentially. This technical complexity widens the operational gap between leading Taiwanese foundries and their global pursuers. Maintaining market leadership requires absolute synchronization of international logistics. Foundries operate as centralized clearinghouses, precisely managing the arrival of raw chemicals and silicon ingots from worldwide suppliers to align with strict production schedules. The physical environment within these factories requires unparalleled precision. Clean rooms are engineered to be thousands of times cleaner than hospital operating rooms, using advanced air filtration and seismic isolation technologies to protect delicate silicon wafers from microscopic dust particles. The scale of resource consumption is immense, with fabrication facilities requiring millions of gallons of ultra-pure water and massive electrical power inputs daily. This demands total integration with national utility infrastructure to maintain uninterrupted operation. Supporting the primary foundries is a vast domestic matrix of small and medium enterprises. These highly specialized subcontractors focus exclusively on niche areas like rare chemical formulation, advanced silicon testing, and precision component calibration. As traditional transistor scaling approaches physical atomic limits, advanced packaging becomes the new technological battlefield. Taiwan leads in combining multiple distinct chips into dense three-dimensional structures, extending computing performance beyond conventional boundaries. The immense capital profits generated by global sales are systematically reinvested into advanced capital expenditures and research. This creates an aggressive financial flywheel that ensures competitors can rarely catch up with the pace of modernization. While no single nation can achieve total isolationist self-sufficiency in the modern semiconductor ecosystem, Taiwan occupies the most structurally irreplaceable node within this vast international web of high-tech industrial reliance. Consequently, the retail pricing of global consumer electronics, corporate cloud subscription services, and enterprise server hardware is directly bound to the factory yield efficiencies and quarterly pricing strategies set by Taiwanese executives. National defense capabilities are similarly dependent. Modern military hardware, including precision-guided munitions and autonomous surveillance networks, relies on high-tier microprocessors that cannot be legally or safely substituted with lower-grade components. The island elite educational pipeline is strategically integrated with this single industry. Government-funded university programs and research labs funnel thousands of specialized physics and engineering graduates directly into the fabrication workforce annually. This extreme concentration ensures that minor operational pauses, whether caused by local seismic events or temporary regional power grid strains, send immediate shockwaves through global financial exchanges and tech sector stock valuations. Because viable alternative suppliers cannot operate at a global scale, these foundries possess unrivaled monopolistic pricing power, directly shaping the net profit margins and corporate strategies of the entire international technology index. Globalized capitalism usually celebrates highly decentralized supply networks, but the physics and economics of semiconductor manufacturing have forced the concentration of foundational digital infrastructure into one hyper-specific geographic location. Dislodging this entrenched position requires foreign competitors to expend trillions of dollars and multiple decades of flawlessly executed industrial policy, guaranteeing that the island economic leverage remains secure for the foreseeable future. Furthermore, the integration of software design and hardware production creates a massive ecosystem lock-in effect. Global chip developers cannot simply move their business elsewhere without redesigning their entire product architectures from scratch. This operational stickiness means that even as international rivals build out physical structures, the proprietary manufacturing software and automation protocols remain deeply embedded in Taiwanese networks, maintaining their operational head start. As global trade blocs increasingly fragment into competing regional spheres, the neutrality and sheer efficiency of Taiwan pure-play foundry system become even more critical for global corporations navigating geopolitical divides. The modern digital economy operates on abstract software, but that software remains entirely captive to physical hardware. By controlling the production lines of that hardware, Taiwan commands the core infrastructure of global wealth creation. Ultimately, by mastering the most complex, capital-intensive, and scientifically demanding manufacturing process in human history, this small island nation effectively holds the master key to the global capitalist machinery.